All right. Oh, question. Yes. Go ahead. All right. So today we're going to be looking at factoring polynomials. Again, it won't be on tomorrow's quiz, but you should, we're going to need it for the test for sure. Okay. Some of this stuff will be a review of like factoring we've done before. Okay. So it'll be good, help for those that still have trouble with factoring and things. But there'll be like one or two new things in here as well. Okay. All right. So greatest common factor is the first kind of like factoring strategy that we want to be familiar with. So it's just the biggest thing that divides all of your terms. Okay? The biggest thing that divides all your terms. Now let's do an example with it. Okay, so let's see an example here. So factor. Okay, and that's the tricky thing here, that the directions that you get when it comes to factoring, they don't give you much of a clue about what you're supposed to do, right? So we'll need to be able to interpret, based on the problem that we see, what we should do. Okay, so there's our example, all right? The first strategy you should always look at, because again, there's not really like first do this, then do this, then do this kind of thing. But I will say that primarily you always want to check to see if you can factor out a greatest common factor first. Anytime you're asked to factor, look for a GCF first. Okay? Because it helps to like lower your numbers, and then maybe you can see other opportunities to factor as well. So looking at this, what is in common to all three terms here that we could divide each one of these three terms by evenly? Okay, so each of these are divisible by 3. Yeah, so let's take a 3 out. Okay, 6 divided by 3, 2. 15 divided by 3, 5. 6 divided by 3, 2. Okay? Are there any additional numbers we could divide out here? Is there any more numbers like that I could divide 2, 5, and 2 by? No. You could say 1, right, but 1's not going to reduce it at all, so 1's not helpful. Yeah. So that's it, right? We're good with our numbers. Is there anything else in common to all three of these terms we could divide out?
An x.
An x, right, okay. So take out an x, okay. And so then our 2x to the third will become 2x to the what?
To the
Second, or 2. Mm-hmm. And then if we have an x squared and we take out an x, it'll be 5 just x, or x to the 1 if you like. If I take the x out of 2x, what's going to be left? Just a 2. Okay. Is there anything else that's in common to all three of these terms here that we can divide out evenly?
No.
No. Okay? There's no more, like these two have x's, but this one doesn't. Okay? These both have 2's, right? They're divisible by 2, but 5 is not evenly divisible by 2. So we're done. That's the GCF. But we have to then further check to see if this thing factors. This is now a quadratic, right? We started with something that was cubic, but now our remainder here, our leftover part, is quadratic, and we need to see if it factors. So, and by the way, that's the GCF right there. Once you kind of get out all of the stuff that you can, what is out front there is the GCF. And that GCF is going to stick with our problem. So we'll still have the 3x. I'm going to kind of go up here. Okay? So we'll start that 3x. Okay, the 2x squared, the 5x, and the 2. But we can potentially factor this quadratic. And I'm going to show you guys that AC method again, right? Just to kind of refresh our memories. All right. What is the A in our quadratic here? It's 2, right? It's that lead coefficient there, 2. Yep. So it's A times C. So it's going to be 2 times. And what's our C term here?
2.
2 as well. Yeah, at the end. So 2 2's. All right. 2 times 2 is 4. And so we're looking for two numbers that multiply to 4, but add to make what from here? The 5. Okay, so we need two numbers that multiply to 4, add to make 5.
4 and 1.
4 and 1. Positive 4, positive 1. exactly right. Okay? So we're going to take that 4 and the 1 that we just figured out, and we're going to break that middle term up. Bless you. Okay, so instead of 5x, I'm going to write plus 4x plus 1x plus 2.
Can I go to the bathroom real quick?
Sure, yeah. Okay. From this, and now we're going to group. So we'll group the first two, we'll group the second two, and then we're going to do factoring by grouping, which is another factoring strategy, okay, that we're using within this quadratic stuff. Okay? So we'll group the first two, and from that first group, what's the GCF we can take out of that first group? 2x. Yeah, so we still have the 3x in front. We have a big parenthesis. I'm going to take out a 2x here, and I'll write like a smaller parenthesis right here. Okay? So I take out that 2x, and then what's left behind? If I take a 2x out of 2x squared, what will be left behind? So just an x, a 1x. The 2 comes out, and then it's x squared is out, so it's just an x. And then, yeah, x plus 2, right? Because that 4x, we take the 2x out. Okay? Plus, what's the GCF of this? There isn't one, right? So 1. 1 is the largest thing, so we'll like pull out a 1. We'll back out a 1 there. Okay, you can see we get the same leftovers, right? Same leftovers, x plus 2. So we'll take the x plus 2 out, and we'll have 3x still, right, from there. Take out the x plus 2. If I take out those x plus 2's, right, what's going to be left behind? The 2x plus 1 there. Okay, and there is our fully factored polynomial. Okay, there it is, fully factored. So if you were to multiply this all back out, you would get exactly this. Okay? So you can check yourself, right? You can do 3x times the x, 3x times the 2, and then take that answer and multiply with 2x plus 1, and you would get this. Maybe in a different order, but the same thing, you know.
Okay.
Question?
How do you get when you're going from the top?
From here
If you like from the top, you're like
to here?
down the line. Like, do you have to put those in the parentheses? They have to be in that order, or could they be flipped?
So right. So just because, yeah. So you're saying, could I put a 1x here and a 4x here?
No, like could you just completely flip both of them? Like, could the 2x second plus 4x be where the other one is?
Yeah, that's okay because it's still addition. Yeah, you could add, you could put them around. Yeah, but I'll say most of the time I would be willing to bet that you're going to be writing them in this order because you're going to have it in standard form already. So you're probably going to be writing it in that order. But you might. So what's more likely, Michael, when you're doing these is you'll more likely maybe have the 1x here and the 4x here. It will factor it, and I'll get you here. Sorry, one sec. It'll factor slightly differently, but you'll end up with the same answers. Like the in-between factoring will look different, but the final answer will still be the same, just a different order. Okay, sorry, Hannah, go ahead.
Can you go through the third section?
Like right here?
Yeah, that into high confidence.
Yes. So quadratics, right? Factoring those can be tricky for students. All right, so there's different strategies you can use. The one strategy that I, kind of encourage you guys to use is the AC method. You guys might be able to taught like the magic X or something like that. Did you use anything like that? Okay, so whatever method you were taught, I really feel like AC is pretty helpful. So that involves taking your A, your lead coefficient there, multiplying with your constant. So get that right, that makes 4. And then that gives you a target. You're looking for two numbers that multiply to make 4, and then add to make 5. And that's always what you'll do. You A times C, that's going to be your product that you're looking for, and then you're going to always add to the middle term. And so that is where, Hannah, the most difficult part is just figuring out those two numbers. I'll try to keep the numbers small so that way you guys don't have too many options. You'll have your calculator to help you with that, etc. Once you find those two numbers, Hannah, those direct you about how you're going to break the 5x up. Right? So we break 5x up into 4x and 1x. Okay?
That it's
Okay.
just the third.
From here to here?
It's from the last step to
Here
the answer.
to here.
Yeah.
Okay, gotcha. So you understand that, like, when you look at this, you can see that I can take out a 2 from both of these and an x out from both of these, right? Because they have them in common. Okay, and we did that here, and then you did factoring here too. When I get to this point, if I look at this, right, I have a product of 3 things, 2x and x plus 2, and here I have a product of 2 things, 1 and x plus 2. Both of these terms, right, because this is like all one thing, because it's all one product, and this is all one product, they both have an x plus 2 in common. Just like these both had a 2x in common, and I took the 2x out, since these both have an x plus 2 in common, I take that x plus 2 out to right here. And then what's left behind? The 2x and the plus 1 will be left behind, so then we put those together.
Okay.
You see where that comes from now? Okay, great. Yeah, good question. We're going to continue to use that AC method. So you'll see another opportunity to use it here in just a second. Okay. All right, let's try another one. Again, our directions are to factor. That's going to be all of our directions today. Factor, factor, factor. Okay. 2x to the third minus 20x. Ooh. Bless you. All right. So Phoenix, can you help us out there? What can we take out from both of these terms? Okay, so we can take out an x. That's right. So we'll have 2x to the what? If I second, and then minus what? 20. Very good. Yep, just like that. Okay. Is there anything else we can take out, Phoenix, that's in common to both of these terms? Anything else that will evenly divide both of these?
2.
Yes, exactly right. We take a 2 out, and there's an x already there, so it just becomes 2x. And then that will become just x squared, and then dividing 20 by 2 gives us?
10.
There you go. Very good. Okay. Phoenix, is there anything else in common to both of these terms?
No.
No. We know we're done with the GCF, okay? Now we're going to see if this thing factors. You're like, Mr. Witt, come on, this looks way different than the last one. It is still quadratic though, right? This is quadratic because it had the x squared there. This is also quadratic, it's x squared. If you don't see it, right, what you can do is maybe add in like a 0x. So I'll do that up here again too. So 2x, x squared plus 0x, right? It was missing a middle term here, the 0x. And then we'll put that minus 10. Okay, let's use our AC method again here. Okay, so what is the A of this quadratic?
1.
It's 1, right? The lead coefficient there is 1. So A times C is going to be 1 times. What's our C in this quadratic?
-10.
Negative 10, right? 1 times negative 10 is negative 10. We need to look for two numbers that multiply to negative 10 but add to make 0. Two numbers that multiply to negative 10 but add to make 0. I want to get off your phones. It might help to think about it a little bit here. Those of you guys staring at your phones right now, I know it's more interesting, but this is going to be on your quiz tomorrow, or it will be on the eventual test and stuff like that. I'm sure what's on your phones will happen. Okay. We need two numbers that multiply negative 10 and add to make 0. Multiply negative 10. Okay, so negative 5 and positive 5 do add to make 0, but is negative 5 times positive 5 negative 10? Yeah, no, it's not. Nothing is the answer. Todd, is that what you're going to say too? Yes. Yeah. There is no answer. Mr. Wig, what? Why would you give us an impossible problem? Because that's what's going to happen sometimes. This is what you guys are going to do. This is what I expect you to do, right? Is to, first try the GCF, then get your quadratic and see if you can factor that quadratic any further. Do all quadratics factor? No. And sometimes you're going to figure that out, right? That it doesn't factor. And so then what do? We're done. This is the final answer. That is as factor that it can get. You can't factor any further. If you want to circle this one too, that's fine as well. Okay, Pete? Sure. All right, Michael, did you say, were you going to raise your hand there? Or? Okay. All right. Let's have you guys try one. Okay, so you guys try this one. Again, just factor. Okay, so 3x to the third plus 7x squared plus 4x. Okay, and I'll zoom out a little bit so you can see some of the. Well, I don't want to do too much there. So there it is. So try and factor this, please. Factor as much as possible. I'm going to say factor completely. Factor as much as you possibly can. add up to the middle term.
Oh, multiply
Set.
12 out.
Yeah.
So, what about here? There's like a 3x will factor,
Yep.
put that right there. Like
No,
this.
inside. Yep, exactly right. Sure.
So, how do you get just x squared for this one?
Like how do you, okay. So,
From 2x squared to just x squared.
so yes, you're okay with how we went from 2x cubed to 2x squared? Are you okay with
Yeah.
that? Yeah. So then you look at this, right, and you're like, is there, because you should always ask yourself, once you kind of factor something out, can I take out anything else? Can I factor any other way? So I look at this and I'm like, okay, this is 2, this is 20, so both of these divide evenly by 2. So you factor a 2 out, right to the front. And then when I take that 2 out, it's now just a 1, right? It's 1x squared. And then when I take 2 out of 20, divide it.
Okay, but then also, does it have to add to be 7 multiplied to get 12?
Yes, but I would say first, before you do the AC method here, again, try and factor out any GCF first. You see there's something in common to all 3 of these terms, factor that out first, then your AC method. Yeah, they all have what? They all have an X, you got an X, and then continue back. Okay. Yes. Yeah, just an X out front, that is right.
Yeah, I know that.
And then, yeah, this is the right idea. Yeah, so you should have,
So then I took out a 3 and I can do that.
and you just have an X left over when you take that out, and that'll be a
Oh,
1.
wait, so that was, so.
Yeah, and a 1, right, and a 1, because when you divide, you use something like a 1. Yes, you should be able to use the AC method there furthermore. Yeah. All right. Let's see what we came up with here. All right, let's go to. Let's do. How about Chris? Chris, is there a GCF here we can take out?
Yeah.
Yes, an X, right? So we'll take an X out, and what does that leave behind when I take the X out of this?
3x squared plus 7x plus 4.
Okay, very good, right? It was X cubed, so it becomes X squared. It was X squared, so it becomes X. It was X, so it goes away, right? It's just 4. And then we're going to try using the AC method here because we do end up with a quadratic. Okay, so our A is 3, our C is 4, so we get 12. Okay, and then so we're looking for 2 numbers that multiply to 12 and add to 7. And were you able to figure that out? Did you get this far, Chris? Were you able to see it as a quadratic?
Yeah, but I'm just looking at that part.
Okay, so what 2 numbers, can you think of 2 numbers that multiply to 12 and add to make 7?
3 and 4.
So yeah, it's going to be 3 and 4. 3 and 4 there, okay? So then the x stays out front, right? And then we'll have 3x squared plus 3x plus 4x plus 4, like that. Okay? We will now group the first 2 and group the second 2. Okay? From this first group, thank you, Chris. We'll pick somebody else. We'll pick on somebody else here. Let's go to Allison. From this first group here, Allison, what can we factor out? What GCF can we take out here?
The 3x.
3. So we can take, for this one we can take a 3 and an x out. Yep, so let's take out the 3x. Okay, when I take 3x out of this, what's going to be left behind?
The 2.
So there's an x squared. If I take out an x, it'll just have an x left behind.
Oh, yeah.
Okay, and then if I take a 3x out of 3x, what will be left behind?
If you take what? The 3.
If I take the 3x out of, if I take a 3x out of this 3x right here, what's going to be left behind? Nothing, right? But since we're dividing, think about it right. When you divide something by itself, like if I do 2 divided by 2, that implies 2, 1. So 3x dividing out of 3x is going to be a 1 left behind there. That's the catch there. So Christian, question?
We're going to do that.
Yeah. And then Allison, how about this second group right here? What can we take out of the second group that's in common to both terms?
Both 4.
Yeah, well, 4, right. So plus 4, what will be left behind? If I take the 4 out of this 4x, what's left?
X.
Yep, and from here?
Plus. Actually, I don't know.
So it's a 4. We divide it by 4 because we pull that 4 out. What's 4 divided by 4? 1. That's all. Okay. If you ever get stuck, right, you can kind of like, I want to say cheat a little bit here, but you know, if this thing factors, you want to get the same thing here and here, right? So if you already got an x plus 1, there's a good chance you're going to get x plus 1 here, but it doesn't have to be. So anyway, all right, we're almost done. These both have an x plus 1 in common, so we'll take that x plus 1 out, and that leaves behind 3x plus 4 there. Okay, and there is fully factored. Okay, just like that. All right, questions on any of that? Nothing yet? Okay, so almost done here. I want to do a few other strategies here. Okay, if you change your minds, you do want to ask a question, just say so. All right, so the other thing I just want to, again, kind of like talk about here is, factoring by grouping is another. We already know how to factor by grouping, though. That's what we've been doing whenever we factor a quadratic, but I just want to talk about it on its own, okay? When you factor by grouping, something that can kind of clue you in that it will work is if you have an even number of terms, okay? Even number of terms. So, for example, here. Okay. So you look at this problem. Okay. First thing you should always check, if we're trying to factor, what's the first strategy I always encourage you guys to try first? Greatest common factor, GCF, right? Look at it. Is there a GCF here? No. The greatest common factor would be 1, which is not helpful, right? These all have x's, this one does not. Okay? There's no numbers in front except for 1s or negative 1s, right? So these all have x's, but this one does not. So GCF fails us. Is this quadratic? Is this a quadratic? No. What is it? It's the highest power is what?
It's cubed.
Cube. This is a cubic. So can we use the AC method here if this is a cubic and not quadratic? No. AC method is only for quadratics. This is a cubic, right? The highest thing is cubic. So GCF fails us. Factoring like it's a quadratic using AC method fails us. So we can give up and say IDK. No. Okay. The other thing we can try here is grouping. That's another strategy you should look for. Okay. So again, do we have an even number of terms? 1, 2, 3, 4. Yes. Okay. So we're going to group the first 2, group the second 2. Now, just because we have an even number of terms doesn't mean factoring by grouping will work. We'll see what happens though. So let's just go ahead and group and see what happens. Okay. From that first group, Luke P, what can I take out from that first group?
They got an
X.
They got an X squared.
X squared. There you go. Good job. Yep. X squared. Okay. Taking x squared out of x cubed is just x. Taking x squared out of x squared is minus 1 there. Okay. How about that second group here, Luke? What can we take out?
Well, that's basically, we can take out a 1.
Yep, just a 1. You got it. Now we got the x minus 1 left over there. Is factoring by grouping going to work here? What do you guys think? Can we continue to factor? Yeah, why? What about this? What do we see here that is indicating, yes, this is working? Okay, even number of terms, that's right, what led us to the first thing. And then if we have the same leftovers, right. That's the other critical thing here, okay? We see these same leftovers, we're like, aha, we know that factoring by grouping is going to work. We take that x minus 1 out, and what's going to be left behind?
X squared plus 1.
X squared plus 1. there it is factored. Michael, do you have a question?
I was just trying to-
Oh. Okay. All right. So there it is. It worked. Okay. So it worked. Excuse me. Okay. Let me show you one more, and then we'll get you guys started on your assignment. Okay. So one more here, and then we'll get you guys started on your assignments. Or you can start reviewing for the quiz. Either one you want to do is your choice. Okay. Okay, same question. Always check when you're asked a factor. The first thing you should always check is to find if there is a GCF. Is there a GCF here? No. These three terms have x's, but this one does not. These could divide by 3, but this one doesn't divide even by 3. That one does not divide even by 3. So no GCF. All right. Is this a quadratic? Could we use the AC method here? Is it quadratic? No. Okay. We have a cubic, right? The highest power is a 3, so we call this a cubic. Okay. So you can't use that. Could we try factoring by grouping here?
Yes.
Yes. All right. So let's try it. See what happens. So group the first two, group the second two. Okay. From that first group, we can take out what there, Luke L?
The 3x squared.
So
X.
just x squared, right? Yeah. No 3 because that one doesn't have a 3, but we can take out an x squared. So x squared, and what will be left behind if I take an x squared out of this there, Luke?
The x cubed.
Okay. So x cubed will become what though? If I take x squared out of that x cubed, what will be left behind?
X.
Just an x. And if I take the x squared out of this, what's left behind?
The 3.
Yeah, just plus 3. Very good. Plus, what about the second group here, Luke? What can we take out of this?
X. The 3x.
Do these? So let's talk about that, right? So so this is divisible by 3. Can I divide 2 evenly by 3? No. So we can't take a 3 out. This has an x, but this does not have an x. Can I take an x out? No. So what's the most we can take out from this group right here?
Just the 1.
1. Just a 1. And so what's left behind is just 3x plus 2. Okay? Is factoring by grouping a helpful strategy here?
Not.
No. Why? What does this indicate? What do we see here that shows us this is not going to help us?
The terms are not the same.
Okay, yeah, the leftover terms here, right, are different. We cannot factor this out like we did the last one, right? And the last one here, they both had x minus 1, so we could factor that out because they had it in common, right? But these two terms here, these have different leftovers. We cannot factor that out. And so it doesn't factor. Yep. The answer is it does not factor. Okay. It's not factorable. At least not with the strategies that we have right now. Right? Might be able to learn another strategy, but so far we're stuck. Okay. So understand that is a possibility. The answer might be there is no answer. Okay. But don't put that for all of them because I guarantee you that will be the exception rather than the rule. Okay. I'm going to give you ones that factor because I want to show you they factor. Okay. I'm not going to give you a bunch of ones that don't factor because then you're not really practicing your factoring. So don't assume they're not going to factor. But if you find out that it doesn't factor, that's okay. That's a possibility. All right. Homework. Yes, go ahead. So I'm going to give you guys a homework assignment. This homework assignment will not be due tomorrow. I don't think. Let me check to make sure on that. Yes. Tomorrow, you do not. So this homework assignment will be due, what's Friday, I guess then, right? Tomorrow's Thursday. So the homework assignment will be due Friday. Why, Mr. Witt? Why give us 2 days to do the homework? Because I want you to get ready for tomorrow's quiz as your primary, work for tonight, okay, or for today in class. So I'm going to put the homework assignment on the board, but I'm also going to pass out that quiz review that you can use right now to start working on preparation for tomorrow's quiz. I will give you some time tomorrow in class to also ask questions, okay? But make sure you've already worked on it ahead of time. I can't spend all of class tomorrow reviewing because we got to take the quiz too. So I'll give you maybe like, 10 minutes maybe to get some last minute review in, but really use your time wisely today.
Does the study guide do not look like the quiz?
Yes, exactly like the quiz, okay? There will be no surprises. You're going to look at that study guide, you're going to look at the quiz, you're like, oh my gosh, Mr. Witt, thank you so much for giving us questions exactly like on the study guide. And I'll say, you're welcome. So there's the homework and study guide. Okay, so let me get you your study guide. Make sure you bring your graphic calculators tomorrow. Okay, you're welcome, because it's going to be super helpful for this quiz. Yes. Okay. You do. Right. Okay. Does anyone want to borrow a graphing calculator? I need a graphing calculator to borrow. No? Okay, so let's get cracking here, folks. Please, please, please. Let's use the rest of this time to look at that quiz review, okay? Don't feel like you have to go in order, right? If you look at something, you're like, I get that, let's move on, okay? That's fine. Do whatever you need to do in order to be ready for that quiz tomorrow. Okay? Yes. Yeah, drink, you said? Yeah, go ahead.